Hey, in today's lesson, we're going to be graphing inequalities. This is a lesson that doesn't seem like it's too terribly difficult, but it does seem to cause a few problems and it's a little confusing. So please make sure that you're really listening and trying to comprehend this. It's a little tricky. Okay, let's look at example 1. All right, first I want to talk about, before I get there, I want to talk about on a graph. Yeah, switch here. On this graph, if Caleb has $5, we could graph that. Caleb has $5, we put a dot. Now the dot that we use is a closed dot. Grab another little note here. Okay, it's a closed dot. So if I had a number line, 1, 2, 3, 4, 5. We'll do 6. And it says Caleb has $5. All right, I graphed it. If he could have $5, we're going to color it in. Let's make another one. 1, 2, 3, 4, 5, 6. If he could not have 5, but 5 is a number that we're going to use as a reference, I'm going to use an open circle. We're going to have arrows that go one way or the other off of this, but we're going to use a closed circle if we're going to graph it. It could be 5. Open means it could not, because if I was just graphing 5 like I did way back when, 5th grade, 4th grade, I could put a dot on the line. Simple as that. This is telling us that it's not there, but it's this way or it's that way of this number. Okay? So let's keep that in mind as we graph. Okay, Caleb has at least $5. At least $5. Okay, could he have $5? Yes, he could have $5. So it could be equal to 5. Could it be more than 5? Yes, the least amount that he has is $5. So his amount, I'm going to put a C for Caleb. Caleb has equal to $5, or Caleb has more than $5. Caleb is more. What he has is more than 5. Okay, so it's greater than or equal to 5 because he has at least $5. He might have more, but he has at least 5. The smallest amount he has is 5. Okay, if the equals is any part of your inequality statement, we're going to close it in because it could be 5. And I'm going to make mine kind of large so you can see it there. It's kind of becoming black, but we'll pretend. And we want it to be greater than 5. He has this, or he has more. So I'm going to color on top here so you can kind of see it. And my arrow can go on forever. He could have $100 in his pocket. My graph doesn't go that far, but I'm going to tell you, this arrow means it goes on forever in this direction. He could have millions of dollars in his pocket, but it goes somewhere this direction. He doesn't have 4. He doesn't have $4.50 or $4.75 or $4.99. He has exactly $5 or more. Okay, let's look at the next one. Tarek has more than $5. Okay, we'll put a T for Tarek. He has more than $5. Could he have exactly $5? No. He has more than 5. So he can't have $5, but that's our reference point. That's where we start. He could have $5 and 1 penny. That's still more than $5. But he has more. So we're going to go this direction, but it's going to be an open circle this time. I'm going to color in at the top here so you can see it. And it goes on forever because he could have any amount more than 5. I do not color it in because he cannot have 5. This is he has at least 5, so he could have 5. Has an equal sign. This one could not be 5. Vanessa has at the most $5. Could Vanessa, we'll make her a V, could Vanessa have $5? Yes. The most she could have is $5. So she could have $5, so she could have equal to 5. Could she have more than 5? No. The most she could have is $5, so she has less than 5 or equal to 5. Okay, so could she have 5? Yes, that little equal sign tells us yes. I'm going to color it in. Yes, she could have 5 or less. Vanessa has less than 5. So it's going to go this way. Could she have less than $0 in her pocket? Well, if it's in her pocket, no. But she could owe people money. She might have an IOU in her pocket. That would be a negative amount, so it would go to the negative side. Li Chen has less than $5. Li Chen has less than $5. So let's use L for Li Chen. Remember, it has to be cursive. Has less than $5. Could he have $5? No, he has less. He could have $4.99 right here, but he can't have $5. So if he can't have it, but that's our reference point, we're going to leave it open. He could have less, or he does have less. So he could have anything in this direction, including those IOUs that, could go on forever in that direction. All right. So that shows us how to graph with a reference point of 5. The rest of our examples aren't going to have a reference point of 5, but they'll still be graphing inequalities. Okay, let's check this one out. This is a little bit tricky. We kind of have to understand what they're telling us. All right, so Kelly works for Quick Oil Change. All right, my husband changes oil sometimes in cars. He works for a car place, so I think he would be kind of interested in this question. If customers have to wait longer than 20 minutes, so I'm going to underline that, longer than 20 minutes, if they have to wait longer than that for the oil change, that the company does not charge for the service. It's kind of like, oh, there used to be a pizza delivery, and if they didn't get it to you in under 30 minutes, the pizza was free. So it's kind of one of those things you have to watch the clock and see if you get it for free. So if a customer has to wait 21 minutes, they get a free oil change. If the person gets done in 5 minutes, they have to pay for it because it's less than 20 minutes. Okay, the fastest oil change that Kelly has ever done took 6 minutes. So that's saying that they can't do it in less than that. Because, well, there's some things you don't want to do too fast. You want to make sure it's right so your car doesn't break down. Show the possible customer wait times in which the company charges the customer. This one is a two-sided inequality graph. Two-sided because we know the bottom end and the top end. Okay, so our reference numbers, I'm going to mark them here, are 6 because that's the quickest you can do it, and 20 because that's the last point in which they have to pay. Now I'm going to tell you that I know they have to pay anywhere inside that amount. Oops, sorry, I'm 6. 6 to 20. Anytime, any amount of time inside there, they're going to have to pay for that oil change. If it's down here, they're not going to pay for it because it's not going to be done right. And if it's up here, it took too long and they get it for free. Okay, now I have to figure out, is it an open circle or a closed circle? All right, well, let's see. Can he do an oil change in 6 minutes? Yeah, he can do that. So that's going to be included. So that's going to be a closed dot because he can do it in 6 minutes. And will they have to pay? Yes, because we are trying to find the possible customer wait times in which the company will charge. If it takes them 20 minutes, do I have to pay? Well, if customers have to wait longer than 20 minutes, if it takes them 20 minutes, I still have to pay. So yes, if it takes them 20 and a half minutes, I won't have to pay. 21 minutes, I won't have to pay. But if it takes 20 exactly, I will have to pay. So I've got both ends here of my line, and now I just fill in the middle. So this is telling me that anything, I'm coloring it in so you can see it here, anything inside here, anytime within that window, I'm going to have to pay. This is different from the ones that we did here because these ones went on forever in one direction. These have two ends because we know it can't be slower or faster than this, and it can't be slower than this, or they have to pay. Or they don't have to pay, sorry. Okay, let's take a look at the next example. Gurnaz has been mowing lawns to save money for a concert. Gurnaz will need to work for at least 6 hours to save enough money. At least 6 hours. All right, so at least 6 hours. That's the smallest number he's going to be able to work. Let me move that up for you. I'm sorry. There we go. Move my calculator out of the way. But he must work fewer than 16 hours this week. He doesn't want to work overtime. So he must work fewer than 16 hours. He can't work too much time. Write an inequality to represent this situation. And then graph this solution. Did I have to write one up there? No, okay, I'm sorry. I wasn't reading the directions very carefully. Okay, so we're going to have to write an inequality and graph the solution. So let's write it first. Okay, or let's graph it and then we can write it easier. Okay, he needs to work at least 6 hours. Does he have to work 6? Yes. So that's going to be here. He has to work 6. So it's included. Okay. He must work fewer than 16 hours. Now, that doesn't mean that we're going to mark here. 16 is our reference point. But can he work 16? No, he has to work fewer than 16. He can work 15 and a half. He can work 15 and almost 16, but he can't work 16. Although 16 can't be included, it's our reference point, so it's going to have an open circle. Now, he has to work 6, but he can't go over 16, so he has to go somewhere in here. Again, it has 2 endpoints, but one of them is open this time because he can't go over. All right, now we have to write an inequality statement. Okay, so we have to have a variable. Let's make it money. No, these are hours, right? Hours. Let's make it H for hours that he's worked. H will represent the hours. And I'm going to put it right in the middle because it's going to help me to see where it goes. I'm going to put the 6 on this side because that's where the 6 is, and the 16 here. Okay, I'm going to look just at this half. Could it equal 6? Yes. There's the first part of my inequality. Is it greater than 6 or less? I see that it's greater, so it's going to be, H is going to be greater than 6 or equal to 6. We read this as 6 is less than or equal to H, because H is in the middle. Okay, but we know that H is greater, it's the greater part. If I look just at this part, could it equal 16? No. H comes this side, so it is less, so H is less, 16 is greater. H is less than 16, but not equal. We read our inequality statement. If I rewrite it, we would say 6 is less than or equal to H, which is less than 16. Wow, that's tricky. That's tricky. I like to write it up here so I can kind of visualize parts of it as I go. This is the trickiest part right here. If you are unsure or have any questions, that's the end for our video. Please put your question in your ISM. Bring it to class tomorrow.